Hello everyone, my name is Khalid Ibrahim and today I'll be talking about OpenBCI. Before I start, I first want to say that I was inspired to do my second TikTok about brainwaves reading technologies after I participated in Dr. Atkinson's research study, which involved using a 24-channel EEG wireless headset. Their EEG sensors had to be mounted to the user's head with some kind of a paste in order to perform well. However, the technology I'm about to talk about seems much more sophisticated and much easier to use. So, what is OpenBCI? OpenBCI stands for Open Source Brain Computer Interface. The company started 4 years ago through Kickstarter campaigns. However, their brainwave technology first appeared last year. 3 years ago, they started working with heart pulse reading technology and stuff like that. They are trying to create customizable and fully open brain computer interface platform that gives the user access to high quality brain wave data. Their devices are low cost, programmable, open source EEGs that gives anybody with a computer access to their brainwaves. Their goal is to utilize open source innovations in brain science through collaborative hardware and software development. The company has a growing community of scientists, engineers, designers, makers, and a whole bunch of other people who are interested in further understanding of the brain. Their first OpenBCI board, which was released in 2013, they have three versions. From the first model, two of them were released in 2013 and one in 2014. So version 1 was unveiled at Maker Faire in New York City in September 2013. Later on, a factory prototype with an improved design was released in November 2013. And their final first version, or third version, is a programmable over Bluetooth board that was released in April 2014. All three versions were built around Texas Instruments IC, which has an 8-channel low-noise 24-bit analog to digital converter designed specifically for measuring teeny tiny EEG signals. With this version, the third version I'm saying, the company also made computer programs that visualize and process brainwaves to make the raw data much more meaningful. And they have their code available on GitHub so people can expand upon. Now, with their second round, they are creating two things. The first one is called the Ganglion board, and the other one is a 3D printed Ultra Cortex headset. So the Ganglion OpenBCI board, the new version costs only $99, while the old one costs around $250. And the new one can measure 4 biodata input through 4 channels, the brain, the heart, muscles, and accelerometer, and it uses wireless. It also has an SD card and can use the different sample rates, 128, 256, 512, and 1024 Hertz. And in addition to that, their 3D printed headset cost $350 if it was printed by you, and if it was printed and unassembled, cost $450, and if it was fully assembled, it would cost $650. Their headset, the nice thing about their headset is that their EEG sensors doesn't need paste. They have some sort of springs inside the sensors that can push them towards the head of the user. They also have different sizes of the headset, small, medium, and large. And the headset can have up to 61 different sampling locations, and the standard is only 10 to 20. So overall, the company have very innovative ideas, very innovative products, and I think their products might become very popular in the brain researching areas. And that's it. These are my resources. The first two are the Kickstarter campaigns, and the last one is the company website. And thank you.